Okay, everyone, so we'll make a start with the third and final session for this afternoon session here. Okay, so we've got Alex Willmer, who's going to be talking about rehabilitating pickle. So let's please welcome Alex.
Good afternoon, everybody. Thank you for coming. So my name is Alex Willmer. I'm going to be talking about the Python pickle module and whether it can be made safe to use it. Quick show of hands, who has ever used the pickle module? Quick show of hands, who has ever been told you must not use the pickle module? Who heeded the advice? Who didn't heed the advice? Okay, it's a good mix. Right, so I want to start with a bit of backstory. I work for a company called CGI. We're a multinational sort of IT outsourcing company. If you're a government or a council or an NHS trust or a large company and you would like to do some IT project but you don't want to get your hands dirty, then we will get our hands dirty for you. That's the sales pitch. Now we can move on to the talk. In our part of CGI, we use a Python tool called Ansible to spin up a large number of distributed systems. It's a Hadoop, for those that are familiar with it. We quite like Ansible. We got heavily into it. We're writing a lot of roles, a lot of playbooks. But the trouble is that as we're adding more and more to these Ansible playbooks, they've been getting slow. It's taking hours to run, to configure tens of servers. Thankfully, about 18 months ago, a project appeared on the scene called Mitogen. Mitogen is a zero-deploy remote procedure system for Python. All you need is Python on each of your systems and the ability to spawn processes on them, usually through SSH. And there are accounts of this speeding up Ansible playbooks by factors of 10 or more. To give you an idea of what Mitogen can do, this is showing a Python function being run as sudo inside a Docker container on a remote machine, and the result getting chained all the way back up to the originating system. So Bastion is where we called router.ssh, and all this code ran. That caused SSH sessions to be created, sudo to be invoked, and the result came back all the way back to the Bastion. And the only requirement on all of the hosts, with the exception of the Bastion, was that Python is installed. No installation of Mitogen, no need for run nightly billing to be copied all the way down the chain. Mitogen took care of that for us. And this is all really convenient. The problem is that to get the result of run nightly billing all the way back up to the chain to the Bastion host, Mitogen pickles the result. The advantage of this is that it is, in the case of Ansible, blazingly fast. So pure Ansible to run this particular task a number of times created about 4.5 megs of data traffic, and this was very chatty data traffic. So it took about a minute, whereas the equivalent run, I don't know if you can see that on that slide, it's the tiny blue line that's flat at the bottom left. It took 90 kilobytes. So we want to use this, but we need to be able to use it safely. So what is Pickle, for those not familiar? Pickle is part of the Python standard library. It's a way of serializing Python data structures to a string of bytes that you can send over the network, or you can write to disk and read back later. And the promise is that what you put in is what comes out. And that's largely true. Here we see the original tuple of Python types and values being dumped into a byte string, and then that byte string being loaded again, and the output structure is identical to the input structure. You might be wondering at this point, why not just use JSON? The trouble with JSON is, although it is very, very widely compatible in a very standardized format, it only does a subset of the types and values that Python can represent. So if you're serializing your data to JSON, you can't do tuples, sets, complex numbers, very large integers, and some dictionary keys won't come out the same way that you put them in. JSON also can't do self-referencing data structures. They're not very common, but it's a nice bonus to have. Pickle and JSON both work wherever Python is. JSON serializations are a bit more verbose than Pickle ones, though. So those last two are just minor benefits. It's the first two that are the major ones. The trouble is, as a lot of you will know, all the advice is don't use Pickle. If you do, you will shoot yourself in the foot eventually. One of the primary reasons for this is that if you accept Pickle data from some untrusted source, be that a cookie that a browser has returned to you, something that you've received over an HTTP post, or something that you've read from disk, or something that's been sent over the network, decoding that pickle is equivalent to running eval on whatever they wanted to send to you. It is an arbitrary code execution in a very simple way of deploying. And over the last few years, there have been at least 24 vulnerabilities from using Pickle from untrusted sources. And these are largely high or severe severity because of the easiness of getting arbitrary code execution. The classic example of this is that if you were to decode this pickle and you were running as root, you would wipe the entire machine that you are running it on. Decoding this pickle will run rm-rf. The reason for this is that the first character there you see in the string, C, stands for load global, and it will load any callable that Python knows about, and it will automatically import the module for you and then run the arguments that are provided. This is a fairly commonly known scenario and is largely why people advise against using Pickle in a trusted or untrusted state. We can see an example of this. So here I have a pickle that my colleague Rick has sent me, and we'll see what happens when I decode the pickle from Rick. I'm sure it's fine. So I've already read the bytes of this from disk, and I'm going to use pickle.loads, which is the way that you decode a pickle from a byte string. Oh, that's in O. Oh, that can't be good. E. Yeah, okay, so I've been pickle rickrolled. If we take a look at the contents of Rick's pickle, then we can see a similar pattern to the earlier rm-rf example. Python very helpfully provides a web browser module which will open an arbitrary page in whatever web browser you have configured. Now, there is a defense against this. The defense is to subclass Python's default unpickler class and to override a method called findClass. When you do that, you, as the person unpickling, control what Python callables can be invoked. In this case, we've chosen to restrict it just to set and frozen set. So if we go back to Rick's pickle and use our restricted pickler on it, then it's a slightly more complex API because I need to instantiate it first. If I now try and load the same pickle that just launched a web browser, denied. So we're not completely without defenses here. The problem is that this is a very opt-in method. So if anywhere in your code base you forget to use this restricted unpickler, or if anywhere in your code base somebody else on your team forgets to use restricted unpickler, then we're back to getting rickrolled. So if anyone were to call pickle.load, even though we have this restricted pickler around, it would use the default pickler. Sorry, default unpickler. So this is one problem that pickles have that is very commonly cited. And frankly, because it's very easy to get remote code execution, nobody goes any further. As an attacker, if you've got that, you've won. Why would you look for other things? Well, if we would like to make something robust, if we would like to make something that is by default behaving like this restricted unpickler, where if you don't whitelist something, it is automatically blacklisted, then there are other attacks that aren't commonly cited that we need to know about. A few of these are, fall into the categories denial of service, data exposure, and weird machines, in that the one that I've most explored here is denial of service. If somebody sends us a pickle, can they lock up our server for tens of seconds or minutes at a time? Can they cause our process to crash by sending us something that balloons to gigabytes of memory? Can they cause unhandled exceptions? The other two categories of attacks do also need investigating, but so far my investigations haven't borne fruit, so I won't be covering them. The first example that we have of a denial of service with pickles is that the sender of a pickle is who gets to choose what version of pickle is used. To understand that, we need to go a bit into the history of pickle. So if I just create one, something nice and simple, a list 1, 2, 3. I can specify a protocol version. Protocol 0 is the original. It's plain ASCII. So you can send it over channels that aren't 8-bit clean, and it'll work with every version of Python back to 1 dot something. Whoops. What did I do wrong? So I do, thank you. So here we see a protocol 0 pickle, and it's a mixture of new line termination and plain text opcodes. Whoops. The trouble with this ASCII new line termination is it has to be parsed. Oh, that doesn't help because it's Python 3. So it's quite slow to use. We can, as the pickler, choose higher protocols. These higher protocols are binary, they're length prefixed, they are much faster to decode. But if we as the defender want to restrict it to higher protocols that are binary and faster, we cannot use the plain pickle module because the pickle module doesn't let us restrict an incoming pickle to version so-and-so. The result of this is that an attacker can send us a 1 megabyte file that will take us about 10 seconds to decode. And if the transport is gazipping this, it will compress very well. So for perhaps 50 bytes on the wire, they can tie up our server for tens of seconds, and they can send us this repeatedly. If we use protocol 1 or higher, which is binary, then it's better by an order of magnitude. The worst case is that it will take a millisecond to decode. So this is one thing that we need to address. Another attack that we need to address is what's termed the billion laughs attack. Now, this is a general class of attack. It doesn't just apply to pickle. It applies to any data format that can self-reference. So examples of this include YAML, compression formats like zip. XML is a classic example. And if an attacker sends us a billion laughs payload, then what will happen is that the original payload is very small. That's maybe 100 bytes. Okay, 500 bytes. When we unpickle it, seems pretty good. Came back almost instantly. The trouble is when we try to then do something with that data, we might reserialize it in another format. We might try and log it. We might try and write it as JSON. So if I try and print that, those 500 bytes turn into, it'll get there. Maybe it won't. Okay, something's gone wrong. Yep, so they've locked up, for a few hundred bytes, they've locked us up for hours. Unfortunately, we don't have a defense against this yet. There is work that's been done to mitigate this in the XML and, well, particularly in the XML world, but at the moment, the best I can do is Control-C it. So those are the attacks that I have demonstrations of and that I've found definitely need addressing. There are other possible attacks. Pickle itself, the module, the set of all valid payloads that it will generate is much smaller than the set of payloads that unpickling will accept. So Pickle is implemented as a virtual machine with bytecodes and a stack. And the behavior is literally implementation defined. So there's been no formal methods on this. So this is another area that we need to address before we can consider pickle anyway safe. That brings me to the end of the discussion of security vulnerabilities. There is one other issue with pickle that is not of a security nature, but is of a reliability nature that should be mentioned. Pickle is, if you trust the sender and the receiver, or if you mitigate the security things well enough, it is possibly reasonable to use a derivative of the pickle module, not pickle itself. However, if you are using pickle as a long-term storage mechanism, you are still setting yourself up for trouble in the future. The way pickle reflects the internals of your classes and the packages that you use and the libraries that they contain is quite fragile in the long term. It is very possible that if you save a pickle to disk today with version 1 of some library that you depend on, that depends on something else, that depends on something else, when you come back to read it a day or a year later, it will refuse to unpickle. Or it will unpickle and it will give you very weird results. It's a very worthwhile article by a person by the name of Evie that I recommend reading. The use case I am looking at is only pickle derivatives for use on the wire. So that brings me to the end of my slides. I have one more demo to show, which is a work in progress of a cut-down version of pickle that addresses the protocol downgrade attack and the arbitrary code execution attack that was demonstrated. I should emphasize that it doesn't yet address the billion laughs attack. If anybody wants more information or to read further about these issues, all of these links will be in the slides that I'll be posting online. The GitHub repository that I'm working out of, which I'm calling Pickle Fuzz, will include these slides and also has a README that describes the things that I've gone into today. Finally, if you were interested in working with Ansible and Hadoop and Python, and you are in the Southeast, then please get in touch, because as everybody else is, we are hiring. I'm available via email, Twitter, or catch me at the conference. Thank you.
Okay, thanks very much, Alex. Do we have any questions on that? Are you happy to take? You okay?
Questions is good.
Are you okay?
You mentioned camel instead of pickle. So 2 questions. One is, are you aware of any other alternatives, and are they efficient on the wire, I guess?
So camel, I'm not so much mentioning that article because I'm saying use camel. I'm mentioning that article because it has a very good explanation of why pickle is bad for storing something longer than your process will live.
Okay.
I'm not saying don't use camel, just I've not used it, so I can't say either way.
Okay, fine.
Yep.
Are there any more questions for Alex? Okay, we won't have time for everyone, but are you free afterwards to,
I am,
to
yes.
chat? We'll just,
I'll stick around the stage after.
I'll take this one purely on the basis that it was closest to me.
Since the security vulnerabilities of Pickle are so widely shared and known, how come the official Python committee is not doing something to address them, and instead we need to hack around it?
So the mitigation I showed for the arbitrary code execution solves one particular instance of a problem. The wider issue is that the pickle module was written, I don't know, 20 years ago, original version, and it dates from a time when the internet was a more innocent place. Nowadays, the attitude has to be, if it has not been battle-tested, hardened, written with security in mind, you have to assume it's bad. My efforts so far improve matters, but they do not bridge the gap entirely. You still should, you should certainly consider pickle dangerous until proven safe.
I was wondering if you'd looked into, you were looking at blocking the reduce attack directly. Have you looked at secondary attacks like dictionary object poisoning or passing ordered dictionaries and passing func partials to overwrite methods and all that stuff that even if you stop reduce still allows arbitrary code execution? Have you done research into that area?
Not so far. I have, as well as trying to address the global opcode and the reduce opcode problem, I have tried fuzzing inputs to the pickle module. So far, inconclusive. I can't tell if I'm fuzzing it wrong or actually it's a lot better than people thought. It's probably me doing it wrong, but we may get lucky. Please.
He said to catch up later. We'll have a chat with you.
Thank you.
Okay, well is there one, have we got time? Yeah, we'll take one more then.
Okay.
Making me walk here. Yeah, it's definitely the last one, this distance.
So you said you were trying to get Mitogen to work and the issue is pickle. Might the easier solution to be to make Mitogen work with camel?
Possibly, yes. I do confess that the original goal was getting Mitogen safe to use. The goal mutated into, oh, this is a really interesting problem, I should look at pickle.
Okay, well, once thanks again to Alex. We can all agree that was a great talk, so thank you very much.
If anybody wants to ask further questions or you'd like to know more, I'll be here for the duration, for 10 minutes into the break. Thank you.